Did you see the slides now?
Yes.
Okay.
Yes. Yes.
Now let's start with chapter 3. That's name is Newton's first law of motion. Or we know later on that it's the first Newton's first law of motion. It's a law of inertia. Now Galileo in motion. Galileo argued that only when a friction is present, it is a force needed to keep an object moving. Now, he said that if there's any object that is moving, to stop this object from moving, to obstruct this object or to make it stop, to force it to stop, you need a force. And this force is a friction. So if you see any object that is moving and this object, while it's moving, it stops, it's because of a force. This force is a friction. So what is the friction? Friction is a type of force, like the normal force, like the gravitational force, like the push or pull force. It is a type of force. Its name is a friction. But this type of force that acts between the two materials. If you have now, where's my pen? If you have now, as an example, you have a car and you have a street here. Now, between the car or between the wheels and the street, you have a surface. This surface that touch between the wheel and then the street. This between them, there's a force. This force that makes the car to not moving quickly, to make her to stop moving sometimes. So there's a force between the wheel and the street. This one, it's touch the street and touch the wheel. Now, why this force is why it's existed? Because of what? Because sometimes, as you know, that the surface of the street is not smooth. It has some irregularities. And also the wheel. The wheel is not smooth. It has some irregularities. Now, due of the irregularities between the surface of the wheel, as an example, and the street, because of these irregularities, the friction will be happen. Now, and even some smooth surface, even the smooth surface also, that I mean that not the smooth surface, it has an irregularities. Even though that it is very smooth, it has an irregularities. And this irregularities, it's very, very, very tiny. It cannot be seen just by microscopic. That these irregularities that also obstruct motion, that make a force to stop the motion. Now, if there's no friction, as an example, and it cannot be happen, there's no 100% in any surface that there's no friction. There's a friction everywhere. But if there's, as an example, if there's no friction, the moving object will need no force to stop it, to keep it in motion. If the car is moving on ice, as an example, there is no force to make it stop, to stop motion. There's a force. It will continue moving. Why? Because there's no friction that makes her to stop. Now, so Galileo tested his idea by rolling. The scientists, somebody says that there's no friction, and the others say no, there's a friction. Somebody says no, if the car or the ball stop moving because the energy in the ball is finished. That's why it stopped. Somebody else say no, because there's a friction that makes the ball stopped. Now everyone, he wants now to give an proof. Just let him see that the ball was stopped moving because of a friction, not because of the energy, as an example, in the ball. or just because another thing he tried to prove. Now let's see how he did. He tested his idea. He tried to roll a ball along a plane surface, like here. In the first one here, he put a surface. This surface, its slope is downward. Okay. He told them that the ball now, as you see here, it's moving downward. Why it's moving downward? Because of the Earth's gravity. Since now it's moving downward because of the Earth's gravity, the speed will increase. But if you put the ball to go now upward, so the slope, as you know now, it will be upward. What happened with the speed? It will increase? No, the ball it moves against the gravity.
It will go down, not up.
Yeah, no. If you want now to move it, you let the ball to go up. I didn't mean that you let a ball do what did you want.
Yeah,
You
okay.
put a ball. You have to put a ball and you push it to go upward. So since the ball now will move against the gravity, so its speed will decrease. Now, what if the other thing that he said that if I put the ball to be rolled on a smooth horizontal surface, on a horizontal plane. On horizontal plane, I mean like this. Okay? On horizontal plane, the velocity will not increase or decrease because the gravity of the gravitational force will not affect it. So what will happen? On the smooth horizontal surface, it's not move with or against the gravity. You put a ball, and this ball now, there's no slope for it, no force that acts on it, so there is no speed change. So he told, then after that, he said that if the friction was absent, so a ball moving horizontally will moving forever. There's no one stop it. And later on, I will set you to see how the graph or how the graph how it will be. If you have a ball, and this ball now is on the horizontal surface as an example. Now, this ball, if there's no friction here. If this ball, as an example, move on ice surface, it will not stop. It will continue to forever. It will move forever. Why? Because there's no friction make it to stop. And there's no need to push or pull. There's no need to act a force on it. But if this ball, as an example, continue on moves on a horizontal surface and you push it with 5 Newton as an example, after some after many meters or after the distance, after a greater distance, an example, it will stop. It must stop. Why? Because there's a friction. But if you put a ball on a smooth surface, yes, or the surface without the friction, it will not stop. Now, he says that also. If you bring a ball and you put it into two inclined surface, as you see here, the ball starts moving down, then it will continue, then it's moving up to reach its final position, to reach the same height. What's this? Okay. Now, the second thing, you say that if I made now the distance to be greater, okay, here as an example, 2 meter, 2 meter, 2 meter. Here, if you put it like this. If the distance now will be greater than the first step, what will happen? The ball also it rolls a greater distance now. Then it will reach the final position. And the third thing here, he say that, but if there's no friction, he told us, I know that everyone know that if you put a inclined surface, it makes the ball go up. But why he put in his proof the inclined surface? He want to told them that if you put a surface that obstruct moving, it will stop. And this surface is like friction. If you put a surface with an angle, it makes the ball stop. But if you put a surface but without angle, without friction, it will continue. And it will never stop. So if the angle of an incline of the second plane were reduced to zero, as we saw here, it reduced to zero. There's no angle in the C. Since now there's no angle to it, so there's nothing will make the ball to stop moving. Nothing will make because of that the ball will continue moving because there's no friction will stop it. So he say that the angle zero, it's like there's no friction. But here, if there's an angle, yes, it means that it's like there's a friction. Now, but another scientist, he say that no, this ball will stop moving not because of not because of there's no force, because of the nature of the ball. But now,
Teacher, can you repeat what you say now?
here, you mean here, the slide? Did you mean the slide?
Yeah.
Okay. Now, here, he said that the angle of the second plane, this one, it was like this. And here we have an angle. This angle, it seems like friction. If you put an angle on any surface, it's mean like you put a friction on the surface and you let the ball to stop moving. Imagine this. The ball would go down, go up, go down until she stops. It's mean like this angle, it's like a friction that makes the ball to stop. But if now this one, but if now the angle will be zero, there's no inclined angle, what will happen with the ball? It will continue moving forever. Now, so no angle, it will moving forever. No angle, it's like no friction. And I told you before 2 minutes that if you put an inclined angle, like you put a friction. But without an angle, it's mean that without friction. So the ball now will continue moving. But other scientists, he say no, not because of the friction. He say that because of the nature of the ball, that's why it's she wants to go back to its rest. Yeah, to go back not because of the nature of the ball that she tends to go back to its rest. Now, that means that every everybody in the on the earth, it has a tendency to keep it moving in natural, and nobody else wants to change its motion. If I am moving, please keep me moving. If I am on state, on rest, please keep me as I am now. So nobody have attained to change its state. So this is now, we call it an inertia, the property of a body to resist change of its state, we called it inertia. I will repeat. There's no every moving body. It's like to keep its state. I am the chair is stopped. The chair is at rest. He have attained to stay at rest. And if the ball is moving, he like have a tendency also to stay moving. I didn't like to push the chair or to uh, to kick a ball. That's property of this body, of the chair, or of the ball, or of the table. To resist change of its motion, or its state of motion, we call it inertia. That will keep us to go to the fourth lesson. Now, I'm sorry, the third lesson. It was for yesterday. Now I will start with the fourth lesson. That's for today. That will go us to the lesson 4. That we are talking about the Newton first law of motion. We call it also law of inertia. What did the Newton's first law state? States that every object continues I'm sorry, in a state of rest or a uniform speed. Every object, if the ball is kicked, if I kick the ball, it will continue moving in the same speed. Or if the chair is at rest, it will be at rest unless it's acted by non-zero net force. The ball, the chair will stay at its place unless Rose, as an example, come and change its or push it or change its state. If she want now, she push it, she change its speed, she change its state. So this is, we call it law of inertia. That the chair will stay at its place unless Rose come and change its state. And also the ball will stay moving at 3 meters per second, as an example, unless Ragad come and kick the ball and let the ball moving now with 5
So
meters per
unless a
second.
force touch it.
Yes, if there's an unless non-zero force will act on it. So now the Newton first law, we call it also the law of inertia. It is a restatement of Galileo's idea that the force is not needed to keep an object moving. Now, let's talk about object at rest. Simply put, things tend to keep on doing what they are already doing. If you keep the chair at rest and go to sleep, when you wake up in the morning, you will see that the chair will be at the same place because it has a tendency to remain at rest. There's no people come, or no, there's no person come and change its place. So there's only if the force that's act on this chair, it will change its state. Look at here. Objects at rest tend to be at rest, like the candle, the cup, anything, the table also. It will be at rest, even there's nobody act on it. Now, what about the objects in motion? Now, let's see that there's an object that's moving now. In the absence of forces, a moving object tends to move in a straight line indefinitely. Okay? If there's no, and the absence of forces, so a moving object will like to continue in a straight line. But now, if you toss an object, if you act a force on the object in the space, the object now will move due to its will move forever due to the inertia. It will move because now I act a force on it.
Teacher, can you explain the last point?
Okay, look here now. Okay, I will explain by these pictures. Look here now. Who can tell me what the picture tell us? Yes.
Yes, teacher.
Who can tell me what's happened with this picture?
Can I say?
Yes.
So at first, the boy and the dog were at state of rest, but then the dog decided to move, so he moved very fast, and due to that, the child fell down.
Yes. So what's meaning in physics?
Shall I say or someone else?
You. Yes. Continue.
That objects at rest stay at rest unless a force acts on it, and objects moving stay moving unless a force acts on it.
Yes. Thank you. Look here. He's moving. Oh, yes. He is moving. But then the dog come and act a force on it. That's keep it to change its state. Then when he's moving quickly, the ball will fall down. That's mean, yeah, Rose. That's mean.
Newton's law of inertia.
Yes, that's he tends to stay at his state. But when the dog, like a force, when he want to push them, when he moved them, he let him move. When he let him move, so the boy now will move because there's a force acted on it.
I think this is the same logic as when you have glasses on top of a table and you remove the cloth under it and the glasses stay as they are.
Yes, thank you. As she said here now the trucking, she's moving. He try now to stop its motion, but nothing happened. She will continue him to move. Now here is the last slide, I think. Yes, here. A force of gravity between the sun and its planets hold the planets in orbit around the sun. If the force of gravity suddenly disappeared, in what kind of path would the planets move? Here you have a sun, and you have a planet, as you know, and the Earth and the other planets are moving around the sun. Why? Because of the gravity that makes them goes around the sun. What will happen if the force will disappear? How the moving will, how they, what's the kind of the path will be? How it will move?
Towards Earth.
What?
They will move towards Earth.
Can you repeat? Your voice is not clear.
They will move towards Earth.
No, it's not centrifugal forces.
Can I say?
Yes,
They would move in a straight line forever.
thank you. It will move or
There is no
each
force to
planet
stop
it
them.
move. No, each planet will move or would move in a straight line at constant speed. Now imagine that if there's no gravitational, or there's no force, make them move and a centrifugal force or a moving force around the sun. If there's no force, the planet will move in a straight line.
They
That's
will
our
move. They will move
yes.
tangent to the circle in which they stopped, right?
Yes. Here, as an example, if you have a circle, I mean its name in the street, the And here you have a car. Here you have a circle, and here you have a car. Why? What keeps the car moving?
Centripetal force.
Thank you. Centrifugal force. This one, it keeps the car moving around the
Center.
the center. Yes, you can say, or the circle on the street. Gas man, keep it moving in a circle. But if there's no car or no force, no centrifugal force acting on it, the car will move towards it. So it will move in a straight line. That's our lesson today. This centrifugal force, not with you, it's in chapter 9 maybe, or yes, or chapter 8, I think. We will talk, inshallah, next semester. Next semester. Okay, that's our lesson today. Do you have any question?
No.
Teacher, not regarding physics, but in math, do we need to solve all the questions in the workbook?
No, the teacher say the even numbers.
What?
The teacher say the even numbers.
See, guys, in the previous years, I chose some numbers of some questions in the book, and let the girls to solve it, because I saw that the questions in the book, like apply and challenge, as is more harder than the workbook. Actually, this is my opinion. Now, what did you like? What did you like to solve the workbook and send me the answer, or the selected question from the book?
In math or in physics?
Math.
No, the workbook.
It doesn't matter whatever. We just solve questions.
Like the workbook because a lot of questions have.
So what about if you solve the workbook and the book, which which one is harder?
How about we solve both?
Actually, the workbook teacher because the questions of it, like not everything we took.
I feel like in the workbook, they're just the same style of questions over and over again, while in the book, they bring different styles for different questions.
Yeah.
So in the book, it's harder than the workbook.
Okay.
Yeah.
Sure.
Yeah, because I see, like, I noticed, like, how, like, the questions in the problems, how it's repeated the same idea but different numbers.
Yeah.
I feel that this is the workbook. Yeah, I mean, it is not 25x, it will be 20x. So the more practice, it's okay with you. You
The
more
book has
practice,
a
you can
variety
solve
of
it.
questions.
But if you
that are
have
different.
many ideas, wait, because I want to, if you want to solve many ideas, you have to go to the book. Sometimes like graphing calculator, sometimes like something related to chemistry. This type of question you can skip it. But you have to ask me before. But actually, I will send you. Or okay, if you want, you can solve the workbook and the book as you want. So please tell me workbook or book, and tell me later on.
So teacher we can solve the both. Then send it to you.
No. Let's
I think
rethink.
the book is better.
Stop. It's okay. I have another idea. I will let you to solve the book and send me the answer, and I will put on the course material the solution of it, and then I will put so I will select some questions from the book, and I will put it as an online assignment to solve it also and send me the answer. I mean both of them. Okay.
So the
For
homework
the
is from the
for
workbook
the for
and
the
the
work
assignment
for
is
the
from the
workbook,
textbook.
yes, the assignments will be from the book, and I will choose some questions. I put it for you, and for the workbook, every time if you have, we will continue the book, the lesson. I mean, you have to solve the even number of the questions.
Okay.
Okay.
And then send it to you?
Can you repeat?
And then we have to send it to you?
Yes, yes.
Okay.
Do you have any question also? Girls, please. I'm not talking with Haneen and Susan and Rose who every time talking with me. I'm talking with the others now. Please, guys. This chapter is so easy. With that, chapter 9 and 10 and 14. 14 is a very hard one. Ask the previous girls. Wallahi, it's very hard. So please, girls, every time after when I finish the lesson, please study it. I beg you. Because
Is,
wallahi,
is
chapter
chapter
8,
14 trigonometry?
yes.
In algebra?
Oh,
Yes.
trigonometry is very interesting. It's just a couple of rules. You know them?
Yeah,
Yeah.
I like
Yeah, we took it in geometry last
I
year.
like it. I like it so much. I like
Yeah,
it so
it's
much.
really
It's
amazing.
hard. It's
But
interesting.
it's hard. Because you have to make to prove something to prove to but it's very 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 wallahi I like it but it's hard because
It's
when
very
I
interesting
was
to study.
it's interesting but it's hard. You have to think out of the box because every question it has an idea. It's not repeated. Okay, now and I have to know you have I want you to know something also. In this new edition of geometry they add a new chapter for us also. And I didn't teach this chapter before. So that's why we have to move faster also. So every 2 periods we will talk about a lesson. Okay, you have chapter 8, then chapter 9, that they are talk about geometric and arithmetic sequence and series. I don't know if you know it before. Then we are going to talk about in chapter 10 about
The conic sections.
conic section, thank you. After that, we'll go to the geometry. We'll talk about how can we find the area of the trapezoid, the kite, and two-dimensional shapes. Then we are going to talk about how can we find the volume on the surface area of the three-dimensional shapes. And then we are talk about how can we find about the circle and the center circles. And I think we will go also to chapter 14, which are talking about, in it about probability. That's all of these chapters in the first semester, inshallah. And in the second semester, we will go back to chapter 11 also to talk about the probability. In chapter 12, to talk about matrices. In chapter 13, I will choose 2 or 3 lessons from it that's related to chapter 14. And in chapter 14 will be our final second semester final, inshallah. So please, girls, all of them is not easy as the previous grades. It's algebra 2. Algebra 2 in America, it will be taken grade 11. It's not grade 10 as we have here. So please, girls, study well. Okay? And as you also, I told you yesterday, after we finish this chapter, maybe after 1 week or 2 weeks, we will have an online quiz. Study well. And if you want to continue,
Even
no
for
matter.
the physics?
The physics, I don't know. If after we have material, I will tell you that we have a quiz.
Teacher,
Another
when you
thing,
download this Microsoft, we should copy it in the copy, yeah?
when you download what?
This Microsoft, the PowerPoint, this one. We should copy it from the copy, in the copy.
You mean the slides?
Yeah. We should run it in
Yes,
the copy.
or you can open your book and highlight the what I wrote here because it's the same as your book.
Yeah.
What else did you want to tell you also? By the way, this chapter 10, sorry, the materials in grade 10, it's actually as the same as SAT 2. SAT 1, it's like grade 7, 8, and 9. And SAT 2 is a grade 10. It's the same as a grade 10. So if you want to continue SAT 2, please focus on this material. Okay, grade 10?
Okay, thank you.
So what
Okay.
about
Okay.
grade 11 and 12?
Grade 11, we will talk about calculus, inshallah. It's not algebra. We will talk about calculus. It means change of numbers, change of everything. In algebra, you talk about the area of triangle, trapezoid, and any
The
shape.
calculus
But
means second in the set.
no, 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 no. It's in SAT 2, level 2. They SAT 2, level 2. You have talk about limits and derivatives. But I don't know who continue it.
Like we should or not.
What?
Like we shouldn't take it and we can take it or not as we want.
According to which university you have to go.
Like in Jordan.
In Jordan, I
Level two.
think that you have to take SAT 2, yes. But I don't know if you need to reach level 2 or no. About
This
what is the major you want to do? If you want engineering, maybe you need SAT 2 level 2. If you
oh,
need, yeah, you have to ask them and then you have to continue.
okay, good.
Okay. So calculus, it's a change. It means a change. You have to create a function from the old function. Okay, so inshallah, when you really grade 11, you can't, Okay, girls,
Okay.
have a nice weekend.
You
So,
too.
if you want to ask me about calculus, you can ask me on WhatsApp
Thank
because
you,
I know
thank you.
the others didn't want to listen to me now.
Thank you a lot.
Okay, thank you so much. Have a nice weekend. Bye-bye.
Bye.
Thank
Bye.
you.
You are welcome. Bye-bye.
Bye, teacher.
Bye.